Hi, I'm Pranath and I'm from Group 30, and today we are going to demonstrate Lab E1 prototyping reduction, and we are going to start with part 1. And for the part 1 we are going to use NOR gates, and this is the data sheet we are going to use. And this is how the setup is done, and this is A and this is B. So we are going to start with for the pin outputs. These are the pins we are going to we have implemented here, 2 and 3, and A is for 2, and pin 3 is for B, and the output goes as number 1, output from number 1, and then it goes to the input of 12 and 11, and the output comes from pin 13, and the 13 is connected to the LED module here, which is the output. So let's start with the first table here, which is A0 and B0. The LED is should not on as in the table. So the next one is A0 and B1. So the LED goes on as there's a input input of 1 here. And next A1 and B0. So A1 and B0 LED should on should on as in the table. So the final one is the A1 and B1. So A1 and B1. So the LED lights on. So that's it. Thanks. Now we are going to demonstrate part 1 for the schematics for circuit 2, and in this case we have used like two gates, which is a NOR gate and an AND gate, and both the gates are connected as in this schematic diagram, and as well all the pin everything is connected as in this pin diagram here. So let's start with for the first truth table. This is A and this is B, and the output is connected to the LED module. And first of all, A0 and B0, you get a output of 0 as in the table, and next A0 and B1, you get output of 1, and next we input of A1 and B0, and you get a input of 1, and next A1 and B1, you should get input of 0. So A1 and B1, we get input of 0 here. So that's it. Thank you.
Hi, I'm Jehovah. So today we will discuss about part 2 of the experiment. So we will talk about the IC, which is 74HC00, and first we look at the supply array, VDD. So VDD, we can measure it on the oscilloscope. So just wait. So we get roughly 3.28 for the output. So this will become our VDD. So 3.28 is our VDD value, and yeah. So now we'll talk about how to measure VOH from the oscilloscope. So as you can see, this has been adjusted. So the curve B is 3.28, which is our output, and curve A is 3.36, which is the channel 1 input, and B is our VOL, which is 80 millivolt. So the typical VOH and VOL, right, you can actually get the value from this data sheet. So this is how we get 3.2 and 0.01. So the VOH is the output, curve B, so it's 3.28 volt, and the VOL for the measure is the 80 millivolt. Okay, yeah, done. So now I'm going to show you how to measure the TPLH and TPHL on the oscilloscope. So first you adjust the graph pattern. So become this fluctuate graph. So it takes times. So you stop the graph and then you adjust the distance between the two graphs. By using change the mode to manual and change the type to time, and you adjust the distance of curve B. So make sure that the line pass through the middle of the curve, and the other one also the same, pass through the middle of the curve of the slope. Yeah, of the slope. Okay. So what we get is the measure TPLH we get is 48 ns. So this will be our measure TPLH. And you need to divide by 4 because this whole IC contains 4 NAND gates. So in order to find one NAND gate of the TPLH of one NAND gate, you need to divide by 4 to get one TPLH of the NAND gate. Yeah. Okay, cool, done. So now I will show you how to do the measure the TPHL from the oscilloscope. So as usual, set the cursor to manual, mode to manual, and adjust the distance between the two graphs. Okay. It is important to set the two lines in between the slope. Make sure it's nearly to the middle of the slope, like this. You can take half of the slope, yeah, to get a more accurate value. Okay. So now the TPHL we get is 28 ns. Yeah. And oh yeah, you need to divide by 4. As just now what I explained, because this is 4 NAND gates. In order to find one NAND gate, TPHL need to divide by 4 and then you get the actual value, actual TPHL for one NAND gate. Yeah, that's all.
And I'm doing part 3 of this particular laboratory. We have a very simple circuit here which consists of 3 components in series. We start off with an AND gate which is connected to a resistor and then an LED. So depending on the input, which is I over here, the LED will light on or off. So this is the representation of that particular circuit on the breadboard. We have a switch-in module which provides the particular input to the NAND gate, which you can find it on the IC over here, and the IC is then connected to the resistor here and the LED. So I'll just switch on the switch module and you can see whether the LED lights on or not. And that's how the LED lights on, and when you switch it off, the LED lights off.
Okay, go.
Okay, now I'm going to explain the part 4 of our lab 1. For the part 4, we have used 2 gates. One is a triple input NAND gate and a quad 2 input NAND gate. So this is the NAND gate, 2 input NAND gate, and this is a triple input NAND gate. So according to the part 4, this circuit has 3 inputs, which is A, B and C, and with a single output where it is connected to an LED module, and the inputs are connected to a switch module over here. So the main outcome of this circuit is when two or more inputs are high. For example, A, B, C are all 1, so light should go on. So let's have it here. So for example, let's say A0, B1 and C1, the light should light on here. So as you can see, A0, B1 and C1, the light is switching on over here. Okay, for the next one, when all 3 are 0, the light should switch off. And finally, let's go for this, where A1, B1 and C1, the light should switch on over here. So A1, B1 and C1.